Important principles for probability. The probability of an event is a fraction or a decimal between 0 and 1 inclusive. That means probability can be 0, probability can be 1, or probability can be anything between 0 and 1. But would it make sense if you were entering something on the calculator to find a probability and the calculator said 7.2? Could you put 7.2 down as a probability? That's not a number between 0 and 1. Anytime the problem is asking you for a probability, your answer has to be a number between 0 and 1 or including 0 and 1. What would it mean for something to have a probability of 0? If I said the probability of my electricity being on when I get home is 0, that means what? No chance. No chance of it happening. Well, there are very few things that actually cannot happen. There are things that are highly unlikely to happen, but there are very few things that have a probability of exactly 0. And similarly, there are very few things that are sure to happen. There are very few things that have a probability of 1. And that's what certain to happen events would have a probability of 1. I think Mark Twain is given credit for saying the only two things that are certain in life, or the only two things with a probability of 1, are what? Death and taxes. I think that was Mark Twain. The only two things in life that are certain are death and taxes. He would be saying the only two things that have a probability of 1 are death and taxes. We're going to round probabilities to 3 significant digits. You don't have to memorize that. Just make sure you're reading the directions in my math lab. Here's a picture of what we just said. On a scale from 0 to 1, the higher the probability, the more likely something is to happen. If the probability is 50-50, you might as well just flip a coin. But a probability of 70% would be more likely than a probability of 30%. Something with a probability of 0 can't happen. Something with a probability of 1 is certain to happen. Now, I just realized I said if something has a probability of 70, and that violates what I just said about probability has to be a number between 0 and 1. 70 is not between 0 and 1. But then I corrected myself and said 70%. What is 70% as a decimal? And that is a number between 0 and 1. All right. The law of large numbers says as a procedure is repeated again and again, the relative frequency probability of an event tends to approach the actual probability. Let me think about what that means. If I flipped a coin twice, what's the probability? If it's a fair coin, what's the probability of a coin landing on heads? 50-50, or if you write that as a decimal between 0 and 1, 0.5. Or if you write it as a fraction, 1/2. The probability of a coin landing on heads is 1/2. Does that mean if I flip the coin twice, I will get exactly 1 head and 1 tail? No, definitely not. What about if I flip the coin 10 times? Would I be guaranteed to get 5 heads and 5 tails? No. But the more times I flip that coin, the closer I'm going to get to having exactly 1/2 heads and 1/2 tails. If I flip that coin 1,000,000 times, then let's say I got 490,000 times it landed on heads. 490 out of 1,000,000 is darn close to 0.5. The more times I flip that coin, the closer the probability I'm observing is going to get to the actual probability, which can be calculated using the classical approach. All right, the rest of these slides are just practice problems. See if you understand probability. Number 1 says, let A be the event of placing a $1 straight bet on the Florida Play 4 lottery and winning. The chance of event A occurring is 1 in 10,000. All right. Let's think about that. I'm placing a $1 bet on the Florida Play 4 lottery. Let me think of another question I want to ask here. This problem really, to be in the homework or in a test, would need to give you a little bit more information, because those of you who don't play the lottery may not know how it works, and I don't, because I'm good at math and I know my probability of winning. But the Play 4 lottery, you just pray and get lucky if you want to, but you're wasting your time. The Play 4 lottery, you have to match 4 numbers. Now, how many possible digits can the first number be? If I had 4 buckets of balls, numbered 0 to 9, how many possible digits could I draw out of the first bucket? 10. 0 through 9 is 10 numbers. So there are 10 possibilities for what I could draw out of the first bucket, 10 possibilities of what I could draw out of the second bucket, 10 for the third bucket, 10 for the fourth bucket. So the number of possible arrangements of 10 and 10 and 10 and 10, this is getting a tiny bit ahead of ourselves. You may not know yet why to multiply, but in 4.4, not Wednesday, but Monday, we'll talk about why you multiply the 10 times 10 times 10 times 10. But that's 10, 100, 1,000, 10,000. There are 10,000 possible combinations if I can choose 10 digits for the first number, 10 digits for the second number, 10 for the third, 10 for the fourth. So that's why the chance of winning is 1 out of 10,000. There are 10,000 possible outcomes, and only one of them is a winner. If the probability, or if A has a probability, or the chance of A occurring is 1 out of 10,000, how do you write that as a fraction? Just 1 over 10,000. The probability of A would be 1 over 10,000. And then how would you write that as a decimal? I always have to put down what I think and make sure I'm writing it with a pencil. Yeah. This is the tens, hundreds, thousands, 1 in the 10,000s place. So the probability of A would be 0.0001. What is that A with the bar over it? Do you remember the word for what that was? Complement. All right. So whatever A is, in this case, A may be winning. The complement of A would be what? Well, what would the complement of A mean? Everything that's not winning is losing. All right. If A is winning, then the complement of A is losing. If the probability of winning is 1 out of 10,000, what's the probability of not winning? How many of those tickets are going to be not winners? 9,999 out of 10,000. So A is winning and A complement is losing. The probability of winning is 1 out of 10,000. The probability of losing is 9,999 out of 10,000. So A complement expressed as a decimal, 9,999 divided by 10,000 is 0.9999. Technically, you don't have 10,000. These are what add up to 1. Either you win or lose. Those are all possible outcomes. And so one of those two things is certain to happen. So the probability of winning plus the probability of losing have to add up to 1 because one of those things is certain to occur. All right. I was going to have to ask you what's bugging you, but that just clicked, right? If the probability of rain is 0.2, what's the probability of not rain? If there's a 20% chance of rain, there's an 80% chance of not rain. Rain would be the event A, not rain would be the complement of A with a line over it. If the probability of having green eyes is 0.12, how can you find the probability of not having green eyes? 1 minus 0.12. If the probability of having green eyes is 0.12, then the probability of not having green eyes is 0.88. Because one of those two things is certain to happen. Either you do have green eyes or you don't have green eyes. There's nothing else that there can be. So the probability of those two events have to add up to 1 because one is certain to occur. One of those two is certain to occur. What does P in parentheses A with a bar over it mean? When you see that in a homework problem, what does it mean? The probability of A not happening. Well, in this case, A is winning. So this is the probability of, well, let me write it this way. Probability of losing. If P of A is the probability of winning, then P of A complement is the probability of losing. Among respondents asked which is their favorite seat on an airplane, 492 said the window seat, 8 chose the middle seat, and 306 chose the aisle seat. I want to conduct a little psychology experiment and evaluate these 8 people who like to sit in the middle. I understand the 492 that want to sit by the window. They like scenery. I understand the 306 that want by the aisle so they can get out more quickly in case of fire. But what are these 8 folks thinking? I have cushions. I have a cushion. If this plane hits the ground, I've got cushions on both sides. I don't think the probability of those 8 being good at college algebra is low. Okay, how do I calculate the probability that if I just randomly choose a person, I'll just happen to choose a person who picked the middle seat? How many people were surveyed? Yep, 492 plus 8 plus 306 is 806 total. Only 8 of those chose the middle seat. So let me write it like you need to write it in your homework. The probability of a passenger choosing the middle seat is 8 out of 806. And my math lab will tell you on each problem whether to write the answer as a fraction or a decimal. Just make sure you're reading the directions. If it says write your answer as a fraction, if it says write as a fraction, it's also going to say write in lowest terms. So if you put in 8 over 806, it's going to be wrong. I'm sorry, you're thinking about the right way, but you're not following instructions. If it said reduce to lowest terms, that's going to be 4 over 403. But if the directions say write your answer as a decimal, how would you write that as a decimal? And how'd you get that? You just divided. 4 divided by 403, and then round to 3 decimal places. To 3 decimal places, what did you say? 0.099. There was nothing after that? 0.0099. And so to 3 significant digits, then that's the 3rd decimal place. That 9 would cause that 9 to round up. That 9 would cause that 0 to round up. And so to 3 significant digits, we would have 0.10. Number 3 is actually the question I asked a minute ago. When predicting the chance that we will elect a Republican president in the year 2012, we could say there are only 2 possible outcomes. Now, if I stopped right there, is that actually true? There are only 2 possible outcomes for party of who we elect president. No, there are 2 likely outcomes, Republican and Democrat, but there are also independents and libertarians and other smaller parties. So you couldn't just say there are only 2 possible parties, but you can say there are only 2 possible outcomes, Republican and not Republican. Not Republican could be Democrat, could be Libertarian, could be whatever. How do you get what? Okay, yeah, I think you just need to hear it one more time. If I ask the question, how many parties could our president represent, our next president, then there would be more than 2 answers. We do have more than 2 parties, although 2 of them are much more likely than the others. But if I say there are only 2 possible outcomes, and one of the outcomes is Republican, what's the other outcome? It's not Democrat, because if you say Democrat, you're leaving out libertarians and Tea Parties and all those guys. But if I say Republican and not Republican, that gets everybody. That's just like when I said green eyes or not green eyes. Well, the blue eyes, the brown eyes, they're both falling into the category of the not green eyes. So you could divide categories of eye color into green and not green, and those would be the only 2 categories. Did that help? Okay. We could reason that there are only 2 possible outcomes, and that would be correct if we label the 2 outcomes. Either the president will be a Republican or will not be a Republican. So the probability of Republican is 0.5 or a half. Why would that not be the logical way to think about the probability that the next president will be a Republican? If there are only 2 possible outcomes, does that necessarily mean they're equally likely? No. There are only 2 possible outcomes for eye color, green and not green, but there are way more not greens than there are green. ayes. So just because there are only 2 possible outcomes doesn't mean each one has a probability of 0.5. They may not be equally likely. And not only that, you may have information about, is one of the 2 candidates an incumbent? In the last election, just the fact that Obama already was president gave him a huge advantage over whoever ran against him. It's unusual throughout history for the sitting president not to be reelected for a second term. So you could use subjective judgment to say that last election, it was much more likely that we would have a Democratic president again because a Democratic president was in office. Now, if a Democratic president is already in his second term and can't run again, then you have to look at other factors like, well, how's the economy doing? You know, how's the job market? How's world peace going? Those controversial issues are subjective in issues that affect the probability of whether our next president will be Republican or not Republican. So that's not correct reasoning because both of those events are not equally likely. Exercises 5 through 12 express the indicated degree of likelihood as a probability between 0 and 1, and really that should say inclusive because it is possibility, or it is possible for a probability to be 0 or 1. A weatherbug forecast for the author's home was stated as chance of rain is 80%. That's not a number between 0 and 1, but how could you write it as a number between 0 and 1? Oh, you had a question? Yeah. Yes. I didn't
understand final out. Is this correct? Why or why not?
Tell me what you did get.
That it is not correct.
You're right.
But I don't understand.
If we only had 2 parties, that would be like heads and tails and just flip a coin. But that's not how we choose our president. We don't choose our president by stamping Republican on one side of a coin and Democrat on the other and then just tossing it up in the air and seeing how it lands. So those 2 possibilities don't have equally likely outcomes. And that's why that reasoning is not correct. Republican and not Republican may not be equally likely based on economics or world events or whether or not the incumbent is running again. All right, so chance of rain is 80%. How would you write the probability of rain? What'd you say? 0.8. When a baby is born, there's approximately a 50-50 chance that the baby is a girl. How would you write probability of a girl? 0.5. What's the probability of not girl? 0.5. When playing roulette in the Mirage Casino, you have 18 chances out of 38 of winning if you bet that the outcome is an odd number. So we're looking for the probability of winning. And on this big spinning wheel, there are 38 places the dial could stop, and 18 of them are odd numbers. What's your probability of winning? Well, give me as a fraction first so everybody will know where you got it. 18 over 38. 18 odd numbers out of 38 total numbers. Now, when I said you don't have to know the words classical, subjective, or I may prove that you don't have to know them by having forgotten one of them. Relative frequency. You don't have to know that terminology. You just have to know how to apply it. If you're playing on a fair table, each of those 38 spots is equally likely. And only 8 of them are odd numbers. So that's the relative frequency approach. Even though you don't have to know those words, you have to know the probability of landing on an odd would be 8 out of 38. When randomly selecting the day of the week, what's the probability that you pick a day that ends in Y? Y. They all end in Y. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. They all have day at the end of their name, and day ends in Y. So if you just put all the days in the week in a bag and shake them up and pull one out, it's 100% certain that you're going to get a day that ends in Y. So that probability is 1. All right. Number 14, what's the probability of an event that is certain to occur? That's like choosing a day that ends in Y. What's the probability of an impossible event? 0. A sample space consists of 10 separate events that are equally likely, like a die with 10 sides. What's the probability of each outcome? It has 10 possible outcomes. Yeah, 1. Each outcome would have a probability of 1 out of 10. Or, if my math lab did say write it as a decimal, it'd be 0.1. But right now, let's stick with fractions that we change to decimals. Let's give the fraction first. In the D part, on a true-false test, what's the probability of guessing correctly if you just guess? How many possible answers are there? True and false. How many of them are correct? Only 1. So the probability of guessing correctly is 1 out of 2. Oops, I wrote that in the wrong place. 1 out of 2, or 0.5. On a multiple choice test that has 5 possible answers for each question, what's the probability of guessing correctly? There are 5 answers. Only one of them is correct. So if you are just guessing, your probability of guessing correctly is 1 out of 5. Which that, I can't read that. 1 out of 5 or 0.2. And number 16, a genetic study involved equally likely genotypes represented as capital A, capital A, capital A, little a, capital A, and little a. If one of these genotypes is randomly selected, what is the probability that it's big A, big A? Yeah, how many possible genotypes are there? 4. If I put them in a bag, shook them up, reached in, drew one out, what's the probability that the one I drew out would be a big A, big A? Only 1 of the 4. Or if my math lab asks for a decimal, then write it 0.25. If there's a 25% chance of big A, whatever that is, would it be unusual to get someone with that genotype? It's going to happen 1 out of 4 times. Is that unlikely? If the weatherman said there's a 25% chance of rain and then it started raining, would you be angry and want to sue him? There was a 25% chance. 25% is not that unlikely. It's less than 50%, but it's not shocking. And shocking is what we've been saying unusual is. So, no, that's really not unusual. It happens 1 time out of 4.